So today we will be looking into chapter 7, that's sampling. So in the method of sampling or in the process of sampling, what are the ways we are going to choose the sampling, how the sampling should be chosen, and what are the methodology we should follow, and how to form an sampling. This all we are going to look into this unit, and we will be looking into types of samplings also. So I will start with the definition as usual. So a sample, as the name implies, is a smaller representation of a larger whole. So a sample is a part or an piece of a whole population. So sample is a part or piece of the entire population where we bring out to conduct a research on that small part or the piece of population to gather to a logical answering position after research to the particular research question. So survey can be conducted in either of two ways, whether it can be census method or can be sampling method. So census method, we have surveys, we have descriptive types and all. Whereas come to sampling methods is a non-parametric method. Here we have two types. One is probability and non-probability. Population. So before getting into sampling, we should understand two things here before starting with the sampling. Which are those two things? The first one is what is population and how population is different from target population. So as we start with a population means an entire group of individuals which has been formed to conduct research. It is an entire group of individuals which has been formed to conduct a research. In a formal way, a population is the entire mass of observation, which is the parent group from which a sample is to be formed. Next, does population has a single meaning? Doesn't mean a different in different situation. Yes, population mean different. Population has different meaning in different situations. So the point here is in the census survey, the count of individuals, men, women, children is known as population. So when it comes to census method or when it comes to census survey, here the population mean man, woman, children. These are population. So when it comes to research methodology or when it comes to particularly to research, here the population means the characteristics of a specific group. So I have an example here to explain it with a clear thing. So here you see the example states that secondary school teachers of who have some specific features like teaching experience, teaching attitude. So what are the characteristics here? Here the characteristics are teaching experience and teaching attitudes. So the population means different. The population has different meaning in different situation based on the area it has been used, whether it's a census survey or it's a research. So it differs there. So you should be very careful while you're defining a population. You should be very careful while you are making a population described. You should be clear and specific what your who are your population and what are their characteristics. So population plays an important role in our entire research. We know that. But how target population is different from population? Let us look into that now. So target population. So what does this target population does? A target population is distinguished by a particular characteristics. It is distinguished by a particular characteristics. What is that particular characteristic? The particular characteristic can be the nature, category, then their group of preferences. By all this, we decide the target populations. So while deciding a target population, what should we remind or what should we should be concerned with? So while you're deciding a target population, you should be considering two things here. Is your target population is your target population as a relevant knowledge? Is your target population can give you an accurate results? That is the two things you have to check. So let's move on to the official meaning here. So by target population means the member of a real or hypothetical set of people or event or objects which we wish to generalize the results of our research. So when it comes to target population, we wish to generalize our results based on this real or hypothetical set of people. Those are called as target population. So while you're conducting a research, in India, now based on the number of book readers in India, you can't conduct a research for an entire India or an overall population in India, but you can make sure that you conduct research on this target population who are involved in reading of books, novels, stories, comics. So those are your target population. So the population is different than a target population. So target population is a distinguished characteristics. It's a type of population distinguished by its characteristics. Those are called target population. So next we have assumptions of sampling. So what is this assumptions? We have homogeneity amid its complexity. So we feel that sampling is always a homogeneous thing, and it has to be conducted with the people who have similar or relevant characteristics, who can match with the generalized results, who can have that correspondence to match the results of your research to generalize it to the whole population. Then possibility of representative selection. Here, while you are designing a sampling or while you are doing a sampling, you'll have to represent the possibility. You have to represent the possibility of selection, whether this sample can be selected. If it is yes, what is the confidence level? What is the confidence interval it should have? Then absolute accuracy, not essential. So here the absolute essential is not that essential, because even when you have a 99% confidence level, you will have at least 0.5% of margin error. So absolute accuracy is not essential, or it is not. So next we have needs of sampling. So why should we use sampling while we are doing the research? So what is the importance, or why the sampling plays such important role in our research? So first, we have to look into this 5 major points that I have listed on the PPT. The first point is economy of time. What is economy of time? It is going to save your time when you have a larger population and you have to conduct a research within a shorter period of time or within a limited period of time, and that the sampling comes to the place there, because sampling takes out a particular group of people from the overall population and bring out the result, and it generalizes the result to the entire population. So that saves your time, then saves your money. So instead of going to each and every individual and collecting data from them, you can have this advantage of sampling, or else taking out a sample population and conducting research on them. It is going to save your money because you're going to use less resources. You're going to use less tools. Then collects richer data. Yes, sampling collects richer data, because when it comes to the method of sampling, we have some scientific approach in it. We have a scientific approach in it. When it comes to, let us take an example of systematic sampling. When it comes to systematic sampling, we have a scientific approach. We will choose the same number or the same person or the same nth number person. If we choose the third person is my, if we choose the third person is my population, the third person of every row is my population, then we'll choose every third person in the row as our population. There is a scientific approach in it, and the data is going to collect will be validated, objectified, and quantifiable data, because it is being applied by a scientific way and it has been collected in a scientific way. It makes more sense. So you're going to have maximum information with less efforts and less time. Utility in experimental study. So sampling is most widely used in experimental cases, because while you're conducting an experiment, you can't go and conduct on each and everyone. For this, the best example is we can take drugs. We can take drugs, particularly to the skincare products. Here, when it comes to dry skin, they have separate treatment. When it comes to what is that, sensitive skin, they have separate treatment. So how will they prepare drugs for this? How are they going to prepare drugs for it? They are going to prepare based on the characteristics I told. For a dry skin, particular drug. For a sensitive skin, for a particular drug. But they are not experimented on each and every person in India who has a dry skin, each and every person in India who has a smoothing skin. But they have taken a sample of people and they have conducted an experiment on them. So based on that result, they will release the drug, or they launch the drug in the market. Then it has a reliability because it is based on the probability theory. Sampling is based on probability theory, where you have the probability of each and every individual getting a chance to record his responses in the research. So it is reliable. So the data it is going to get, it is reliable on that. It has a very validated content on that. So that's why sampling is important here. So as we saw in all these 5 points, the common here are 3 points, which is economy of time, economy of money, and collects richer data. But this two stands as unique: utility in experimental study, and it has reliability. So sampling has two unique features. That's utility in experimental study, and it has a reliability. It has a reliability because it is based on the probability theory. Then up next we have types of sampling. So types of sampling. We have 2 types. One is probability sampling, and another one is non-probability sampling. We will look into each and every type under probability and non-probability deeply in our upcoming sessions. So here, a probability sampling is a sampling technique. Where a selection of a few criteria and choose members of a population randomly. So the probability here, they'll set certain criteria for the population. So whoever meet that criteria, they'll choose that member as a population randomly. So what is the advantage of probability sampling? The most unique advantage of probability sampling is the members of it have an equal opportunity to be the part of sample with the selection parameters. So here, each and every member has an equal opportunity to get selected to be a part of the sample with the selected parameters. As I said, they'll have certain parameters set. So whoever meets the parameter, they will be selected as a sample here. So each and everyone who are selected as a sample, they'll have the equal opportunity to be the part of that sample. And it is a fixed process. It has a fixed process while you are selecting a sample. So we'll discuss that process in the end of this session. So considers every member in the population. It considers every member in the population to bring out a non-biased result. So here we have an example for probability sampling. Let's assume in a population of 1000 members, every member will have 1 by 1000 chances of being selected. So 1 by 1000 means that each member will have 1-on-1 chance. So 1:1 ratio, you will have a chance of getting selected here. There is no chance of a member missing a chance here. So everyone will have their turn, and everyone will be selected, and they have equal rights over everything, and they'll have an equal opportunity. So what is this probability sampling does mainly is, it is going to eliminate the bias. It is going to eliminate the bias in the population and gives all members a fair chance to be included in the sample. So here it eliminates the bias and it gives chance to all the population to be the part of the sample. So under probability sampling, we have four types. We have four types. So the first one is simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. So we are going to study these four types of sampling in a depth explanation. So upcoming first, we have simple random sampling. So simple random sampling is a reliable method. It is the most reliable method in obtaining a data, where every single member of the population is chosen randomly, merely by chance. So simple random, as the name says, here we are going to choose the population. Out of that population, each member or each single member of the population is chosen randomly. They have chosen randomly without any what do you say, scientific method. They are just called out randomly without any scientific approaches or matter of criteria there. It's like random, like toss a coin, head or tail. Then if it's head, he; if it's tail, he. So it's simple as that. Then we have each individual has the same probability. So in a simple random sampling, each and every individual has the same probability of getting selected, because a random sampling gives a chance. It gives a chance to each and every member of the population, and it gives an equal opportunity. It saves time and resources of being chosen to be a part of sample. So it saves the time and it also saves the resources of being chosen to be a part of sample, because it has, say, as the name says, it has chosen randomly. It does not take much time to select a population. You can randomly call out the numbers, and you can make out your sample size there, and you can bring out the sample population there. Two techniques. So what are the two techniques of selecting the population, or the two techniques of selecting the sample? First one is lottery method, and the second one is random numbers. So lottery method. So what is this lottery method? So basically, when it comes to lottery method, the basic idea we have is, we are going to buy a lottery from a shop or from a seller who sells the lottery, and on a one specific day, they are going to call out all the lottery numbers they have been issued, and the one number will be picked out from the box, and that lottery number will be given the prize reward. That is lottery method, basically, as we know in our common terms. But what is lottery method means when it comes to research, or when it comes to particular to sampling? So here, lottery method means it is one of the oldest way. It is one of the oldest way to a random sampling method. So what is this? How it is related to random and lottery method? So even under lottery method, it is going to be random. Let's take an example. As I said in the previous example, it is going to be picked out of the box, out of the entire number of lotteries issued. That one lottery number will be given the prize amount or the gift. But in this method, the researcher gives each member of the population a number. Yes, as I said, there will be a lottery number that will be given to the individual, and based on the lottery number, they are going to identify themselves under the process. And at the day of result, they are going to draw a number from a box randomly chosen. There will be a box. They'll have all the lotteries in it, and they're going to pick a lottery from the box randomly, and whichever number comes out first, those people will be chosen as winners. In the same way, in sampling, they are going to choose the population or the member randomly out of the box, or out in the box. They are going to pick a person randomly, whosoever names comes in the box, or whichever number comes in the box, they are going to pick him as a sample. So that's why I put a display picture as 10, 29, 18, 25, 4, because, well, every individual will have a number, and they are going to pick the number out of the box, and they are going to be selected as a sample. So next we have random numbers, use of random numbers. So this is very, 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 very simple. So here, the random numbers, this random numbers is an alternative method. This is an alternative method. It involves numbers. It also involves numbers. Here also we are going to use numbers for sampling technique. This use of numbers table like the one below can help with sampling technique. See here, just a second. Yes. See here, it's random 1, 69, 24, 40. Is there any order in this? There is no order in this. It's randomly written or randomly chosen. See the way they have, we see the way it is. It's 1, 97, 13, 34, 22, 7, 56. Where is 2 in this? We don't have 2 only. Right? So that's how it works. We are going to choose the numbers randomly. We are going to assign the entire population. Let us take an example. We are going to conduct a research of 100 people, and we need to bring out a sample size of 10%. That is 110 people. So I'll assign the 10 numbers to the population, and I'm going to say the population, the 500, to count from 1 to 10, and I will say people whoever has got the number 3 will be my sample. People whoever got number 3 will be my sample. So at that time, people whoever has assigned a number 3 as their number, they will be brought out as a sample. Understanding the simple random sampling method. So it's nothing but how the simple random sampling works. So here we are going to explain an example where an hospital needs 100 employees, where 100 employees out of 500 employees. It needs 100 employees for the night shift, but it has a total of 500 employees. So how are we going to bring out this 100 employees out of 500 employees? We'll go step by step with the example. So remember, the hospital has 500 employees. That's the total population. Then we should bring out 100 employees. That's the sample size. So first we have to make a list. First, we have to make a list of all the employees working in the organization. As mentioned above, the organization has 500 employees. We'll make 500 names. We will record that 500 names, and we will assign number. We will assign number to each employee. We'll assign number to each employee, like 1, 2, 3, 4, 5, 6, 7, 8. Like this, we'll assign number to each employee. And from this sequential series or from this sequential method, we are going to draw a sample. We are going to draw a sample. Figure out what your sample size is going to be. So here the sample size, as I said, we need 100. So our sample size will be 100. So here we need a random number generator. We need a random number generator to select 100. To select 100 random sample size. So how are we going to use this 100? How are you going to use this 500 to make 100 of sample size? So to select the sample using the sample frame, we should make sure that we have sample size, then then the sampling frame rate and the sampling size. Then after that, if your sample size is 100 and your population is 500, to generate 100 numbers between 1 to 500, so you have to generate 100 numbers. We have to generate 100 numbers between 1 and 500. So how we are going to generate this 1 and 500? So we will choose 100 numbers between 1 and 500. It can be 1, 10, 15, 200, 300, 210, 220, 230. Like this, we will choose 100 numbers between 1 and 500. So next, how we are going to calculate the simple random sampling or the simple random method. So here the population mean is denoted by capital N and the sample size is denoted by small n. 1 minus n, n minus 1 or n into n minus 2, n by 1. So here what we are going to do, we'll cancel 1 minus, we are going to cancel 1 minus n, n divided by n. So we'll have only n by n. So our sample size is n and our total population is 1000. So 100 divided by 1000 will give us 10%. So 10%, we have to choose 10% of 1000, that's 100. So our sample size is 100. So that's we are going to calculate a simple sample size and a simple random method. Next, when to use simple random sampling. So the first one is you have to have a complete list of every member of the population. You should have a complete database of the population, whomever you are selecting. So you should have a complete list of them. You should have a complete contact information of them, so you can access the member of the population selected, and you can collect the data from them. Then next, you have to have the time and resources. You need to have the time and resources to collect the data from the necessary sample size, whether it can be 100, 200, 300, 400, 500. You should have that necessary sample size within the data that has to be collected. And as I said, it should be a known population. You should have each and every information about them. Only then you can use simple random sampling. Next, we have how to perform or what are the steps involved in simple random sampling. So under the simple random sampling, we have 4 steps. That's define, decide, select, collect. So define, here we are going to define the population, who are our population, what are we going to collect from them. Then decide on the sample size. What should be your sample size for your research, whether it's 10, 20, 30, 40, 50, 100. But I'll also explain how we are going to select the sample size. Then randomly select the sample. We are going to select the sample randomly because, as the name says, it's simple random sampling. We will not have any techniques here. We'll randomly choose a number or we'll bring out using a lottery method. Collect data from your sample. Once we have our sample, we'll collect data from them. Define the population. It is important to ensure that you have a complete knowledge about your population, because when you collect or when you select a sample from the population, you should have access to the population. You should have access to the population you have selected so that you can collect data from them. So while defining a population, make sure you define a population whom you know very completely, or when you have a list of population with a complete knowledge about them. That's one while you're defining a population. So how you will define a population? Based on the characteristics you need. If it's employees of an organization, they will be a population. If you wanna conduct research with a customer feedback agency, so there your customer will be in your population. So here it varies from situation to situation, person to person, and from time to time. While defining a population, you should make sure it has a relevant relationship with your research and the population you have selected, so it gives you a proper output without any bias in it. So decide the sample size. So all this time I said we should decide a sample size. So how large your sample size should be? The sample size should be very clear and it should be generalizable sample, because the sample we are going to bring out will be generalized to the entire population. So you should make sure that your sample is generalizable and it is within the size you have been mentioned. So next is how you have to decide a sample size. So out of sample size, out of your total population 1000, how we are going to define the sample size? That is the main work here. And it also important to define the sample size, because if you have more number of sample size, you'll have more cost, you'll have more requirement of time framework and resources when you have a higher sample size. So you should know what size of population or what size of sample suits your research. So there are so many ways of choosing a sample size, but it involves two two configurations or the two key factors. What is that? The confidence interval and the confidence level. So while you are choosing the sample size, you should make sure you choose a confidence interval and a confidence level while you are choosing a sample size. So based on that, you are going to choose the estimated sample size when you are working with this confidence interval or confidence level using the standard deviation. You'll come to know what is the sample size you have to choose. So the common confidence interval and confidence level is 0.95 and 0.05. So 0.95 is the confidence level and 0.05 is the interval level. So I'll be taking you to a practical session now, like uh, how to choose the quantitative or the sample size of the population. Just a second, guys. So, so here we have certain important points to remember. I'll go through them as I scroll down. You can look over them. So here the first one is sample size frequently used to determine the statistics and market research. This is we already know. So I'll show you how your size matters. So here you can see if your sample size is too small, you may include a disappropriate number of individuals, which are outliers and anomalies. So you should make sure that your sample size is not too small. If it's too small, then disappropriate of individuals, and you are going to not get a proper fair results, and your results are going to be failed when you apply for an old population. What if your population is too big? If your population is too big, it becomes complex, expensive, time consuming, and all the results are more accurate. The benefits don't outweigh the cost. So it is not value for the money if you going to have a too much of big population. So here I'll show you how the confidence level is going to bring out the results. Let's take an example we are dealing with. So let us assume I have a population size of 1000 and my confidence level is 95% and margin of error is 5%. So what should be my ideal sample size here? It should be 278. So the 278 will be my ideal sample size. So next we have 90% of confidence level with, we'll try with 1%. So if it's a 1% of error, so out of 90%, 1090% is 900. So 1% of margin error, it's going to give an ideal sample size of 872. Ideal sample size of 872. If you make it to 2%, it is going to give an ideal error size of ideal sample size of 629. If it's 3%, it's 430. If it's 4%, it's 298. If it's 5%, it's 230. So the most widely used margin of error is 5%. Or you can use it as 0.05 while you're calculating in your notebooks or a calculator. But just because it is a technical aspect, I'm telling it in the laptop, so I'm using it. So let's check out for 95% with 1% of margin error. So you'll have 906 sample size if it's 1% of margin error. What if it's 10%? So you'll have only 88. If your margin of error is 10%, you'll have only 88 sample size out of 1000, and your confidence level is 95%. So it's a huge difference, right? So the highest is 10% is going to give you an 88 sample size, and the lowest is 1% is going to bring out the sample size of 906. So why the margin of error matters a lot here is it is going to affect your research sample size or the sample size you are going to have for your research. So for that, you should make sure that you'll have a clear-cut vision on your margin of error, confidence level, and population size so that you can derive at a proper sample size. So I want to try this with, let us take, usually the college students conduct experiment with 400 of population. So the margin of error is 1%, we'll have 385. If it's a margin of error is 7%, it's 132. We'll try the same with 99%. See, it differs from 95, it's 132, and it's 99, it's 184. So it's a huge difference, right? It's a difference of 40, 42. But does a population size and a sample size should be balanced or matched? Yes, it has to be, because as I said, if it's too big, it is going to be complex and it is not going to outreach for your cost. If it is too small, you're not going to have a appropriate accurate results if it's too small. So it's your duty as a researcher to balance between the sample size and the population size to have an accurate results. So this was from here. So next, just a second, guys. We'll jump to the slides back. Yes, we are back on slides now. So yes, so this was the how to decide a sample size. So next we have randomly select. So you are going to randomly select your sample. So how are you going to randomly select your sample? There are two ways. As I said, lottery method and a random number method. Lottery method I have explained in the starting of the session. Here we are going to put, or we are going to assign number to the each individual, and we are going to take out that number from a box randomly, and we are going to choose him as a sample, him or her as a sample. Whereas random number method, we are going to choose a number between the ranges or the interval, and they are going to be our sample. Does both make a sense? Yes, it makes a sense a lot, because of this randomization, you are not going to have bias in your research, and your research will be bias free, because you are going to choose the population randomly without any discrimination based on the characteristics or an quality. You are going to choose the population just based on their random, or by the chance they are going to be the sample of your research. So there is no chance for bias here. That's one. So does randomization works in all the organization? It doesn't work in all the organization, but I can make sure that randomization method works in the area where they have a large number of population with a limited time period, and where they have a particular knowledge about a population or the entire population at that places. Yes, the randomization works truly good, because they have a complete knowledge of the population. They have list of the population are contactable, the sample can be derived easily because the population is already been selected, and the sample will be drawn from the population who are already in the contact. So the method here, the only thing we have to choose is the method. Under what method we are going to choose the sample. Then next, collect the data from your sample. So once we have our sample, we are going to collect the data from our sample. So how are we going to collect this data? We are going to collect this data through the sample, or the sample population we have chosen. We are going to collect the responses from them, and we are going to send a questionnaire, or or you are going to ask them the questions you need to take responses from them, and from there you are going to collect the data. What if some people have missed out, or what if some people couldn't attend the research and they have been backdropped, and they are not able to take up the research work? At the time, what we will do at that time, it is going to lead your research to the bias. It is going to lead your research towards the bias, and your research is going to be affected because those sample size of 4 or 5 has not been those responses are not being recorded. So you'll have a variation in your result. Or the people who sees your result, they'll make sure that yours is a biased research because this number of population has not been tested, or they have not been tested. So what are the advantages? What are the advantages of simple random sampling? So the advantages of simple random sampling is, as I said, it reduces bias. As it is a random method, here there will be no bias in your research. It will be a bias. It's really a bias-free research, and it is easy to pick the smaller sample from a large size of population. It is very easy to pick out 100 people from 500. If you have only 10 people and you have to choose them randomly, it's tough. I agree, because out of 10 you can't choose one or two. But when you have 500 and you just have to choose 100, it's easy. You can choose numbers like 1, 67, 60, 68, 72, 49, 52. Like this you can choose easily, because you have wide variety of population. You have a huge population. So picking out, it's like, what do you say? It's like picking out a piece of pizza from a whole plate of pizza there. Just a piece, just a part of there. You just move it out there. You have a wide variety of pieces. Just a part you are going to take out. That's it. It is a fundamental of data collection. It is a fundamental method of a data collection technique. Because even in the previous days, as I said with the lottery example, this method was used during the lottery announce or lottery techniques, because it was the simple way to bring out the winner. It was completely by chance. It was completely by luck. There was no scientific way there. It was completely by luck. The sponsor or the organizer will just put his hand inside the box. He'll take out the number from the box, and whichever numbers comes up, that lottery, whoever owns that lottery will be the winner. So it is a fundamental method of data collection. It's been from long. And there is no restrictions on sample size. There is no restrictions on sample size. There is no restriction on the sample size. As I said, your sample size can be 100, 200, 300, 500, 600. Based on your wide large of population, you can choose the sample size out of it. It's easy for them. Data collected through this sampling method is well informed. More the samples, better the quality of the data. Yes, as I said, while you are conducting a simple random sampling method, you should make sure that you have a complete enough data here, because the things here are going to change. But the information will be accurate, because population at the early stage or at the pre-experiment stage. While when you have a complete knowledge of the population, your data will be well informed. Your data will be qualitative data, and it will be a quality data. It is a richer data. To be in a simple words, you collect a data that has a more content and a more validity and a more objectified content, because the population is already known to you. That's one of the advantage. When we have advantage, we'll obviously have disadvantages. It cannot ensure the representativeness of sample. Here we are going to choose the sample randomly, so it's hard to represent who is our sample or the identity of the sample. It's hard here, because we have chosen the method randomly, and we have chosen it based on what? Just a number or a lottery method. Nothing the scientific here. We can't say he is the third person, fourth person. We are chosen randomly. Like I'll just call out the numbers 1, 10, 12, 14, 16. Come out. We are going to discuss about particular topic, and this will be done. So it's hard to represent the sample here, because their identity will be nowhere. It does not use the knowledge about the population. Yes, yeah, as I said, it does not use any knowledge about the population. It is just going to be randomized. Because here the knowledge does not matter. What matter is the sample size they are going to collect. Out of the box or inside the box, you have 5,000 people, and you only 100 people out of it. So randomly they'll pick 100 chips. So whichever 100 names that comes, there will be population. Whether that 100 people have knowledge about it or does not have knowledge about it, it does not matter for him. I've chosen 100 sample size, and I'll work on that sample size. Nothing that they have to be. At that time, what happens? At that time, your results are not going to be accurate. and they are not going to be effective, and your result paper or the research paper this year are going to be invalid or the worthless. Sometimes it happens because of simple random method. Then it is interventional accuracy depends on the size of the population. As I said in the advantage, see, better, more the sample, better the quality of the data. More the sample, better the quality of the data. If it's too less, if your sample size is too less, then your data is going to be inappropriate and it is going to be invalid because it does not have any proper representation of the data, because you can't draw a conclusion out of 2 members, you can't draw a conclusion out of 3 members for the entire 500 people. At least you should have a maximum population of maximum sample size of 386 for 500 people with a margin error of 5% at a confidence level of 95%. So next we have clusteral sampling. So what is this clusteral sampling is about? We will discuss about this in the next class.